Welcome to the University of South Carolina College of Pharmacy Podcast. I'm your host, Margaret Gregory, and we're pleased to have as our guest today Dr. Lorne Hofseth, Associate Dean for Research for the College of Pharmacy. Dr. Hofseth, welcome. Thank you for being with us.
Thank you.
For those who might not know you, tell our listeners a little bit about yourself, your educational background, and how you came to be at the College of Pharmacy at USC.
I was born in Canada. I received my bachelor's and my Ph.D. from the same place, Simon Fraser University, where I got a football scholarship of all things in as a kicker.
As a kicker?
Yeah, it rolled out of my days as a soccer player for many years. So that rolled into getting a scholarship, rolled into a bachelor's, rolled into a Ph.D. And I got my Ph.D. in cancer research, and that stemmed from my fourth year of undergraduate. I was interested in the disease cancer, wanted to know more about it, and took a cancer course. Dr. Miriam Rosen taught it, and I asked her if I could work in her lab. She accepted, and I ended up doing my Ph.D. with her. And I got that in inflammation and bladder cancer. During my Ph.D., I had experience in cell culture work and did a human trial during my thesis, and I needed to get some experience in animal work. So I went to a lab at Michigan State University. Dr. Sandra Haslam, who was my mentor there, gained experience in animal work, working in hormones in breast cancer. Coming out of that, I had an average number of publications, so I was average, hunting for jobs. So I quickly got a lot of crickets when I applied, and quickly realized I had to get a second postdoc. So I aimed high, sent my resume out to very high-profile cancer researchers, and landed a postdoc at the National Cancer Institute in Dr. Kurt Harris's lab, a monster in the cancer field in P53 and carcinogenesis. And after 3 years, had over 20 publications, high-functioning lab, high-profile person, and I reaped the rewards of that. So when I started applying for jobs, I got interviews. One of those interviews was here. So in my optimism as an independent investigator, I thought, well, I don't want to compete with my mentor, Kurt Harris, who has, almost 1,000 publications in the field. So I decided to focus on the retinoblastoma protein. So what have we done? We've shown that American ginseng indeed suppresses colitis in mice. Multiple different species, in all kinds of different ways. It works in mice. But now I've submitted a grant to ask the question whether it works in humans. And so in that, I've collaborated with the gastroenterology group at Prisma Health. We are waiting for that grant to be reviewed on March 27th, 2025, to see if we can get the funding to ask the question whether American ginseng works in humans.
Another area that you focused on recently is in food additives, specifically colors and dyes. And red dye 40 among those colorations. The FDA recently banned red dye number 3, and now it must be removed from foods that we consume. What are the issues with food coloring, and how will the FDA's ruling for red dye number 3 potentially impact what you're doing for red dye 40?
Good question. Red 3, like red 40, is a synthetic food dye. Synthetic, meaning it's a xenobiotic. Xenobiotic is defined as anything foreign to your body. Anything foreign to the body, like a bacteria, like a virus, like a synthetic, will stimulate an immune reaction. Meaning there'll be a low-grade simmering inflammation caused by that foreign agent, the foreign agent being synthetic food dyes. So you can envision, and because inflammation is intimately linked to carcinogenesis, Think of colitis, increased risk of colon cancer, pancreatitis, pancreatic cancer, esophagitis, esophageal cancer, cystitis, bladder cancer, and you can go down the list. Any tissue that's exposed to long-term inflammation will have a high risk of cancer. Going back, synthetic food dye, foreign, stimulates an immune reaction, chronic low-grade inflammation caused by continuing to consume those synthetic food dyes from the time you can gobble up Fruit Loops and drink juicy juice, until the time that you die. You were probably consuming those, unless we're paying attention to it. That's how I envision the mechanism of this, and this doesn't really change from that overall mechanism doesn't really change if it's called a synthetic. Red 3 has been knocked out because of studies done in 1987 and 1990 by a group in the Medical College of Virginia. They showed that Red 3 causes thyroid cancers in male rats. And that triggered what's called the Delaney Clause. And the Delaney Clause is a clause in the 1935 Food, Drug, and Cosmetic Act. And it says that any food additive that causes cancer in humans or animals, and that's the important part. This clause says that any food additive that causes cancer in humans or animals can't be used in our food anymore. So, circling back to 1987, it showed that Red 3 causes thyroid cancer in male rats, in animals. The European Union banned it soon after that, I think in 1992, I want to say. But the FDA didn't, and hasn't until January 15th of 2025. Typically, the FDA is more conservative when it comes to either banning or approving things. They need a lot of data. Companies that have a direct interest in selling this stuff are publishing peer-reviewed papers saying that Red 40 and Yellow 5 don't do anything to mice in our model. And so they, I think, would have vested interest in selling synthetic food dyes and them publishing. But so 35 years after the Delaney Clause was triggered for Red 3, we finally find ourselves with Red 3 coming out of our food in the U.S. Most importantly, public awareness. The social media coming into play over the last 10 to 15 years. I've seen a lot more awareness on social media about artificial food dyes. And so people are starting to gain knowledge, understand what they're about. That leads to change.
As a College of Pharmacy, I think a lot of people expect that what we do on a day in, day out basis is train future pharmacists. They come here to earn a PharmD. We also provide graduate level studies to earn Ph.D.s in pharmaceutical sciences. But part of what's going on behind the scenes that I don't think a lot of people are aware of are the different types of research being done. Alzheimer's research, colon cancer, breast cancer. Why is a College of Pharmacy conducting this type of research? Why is it important to the community?
A College of Pharmacy, one of their main tasks is to educate and provide a good education and a good environment for success in the clinical setting. But we don't discover without doing experiments. If we can't move forward in our understanding of drugs and how they work without doing experiments. There's a lot of us that run the gamut across our faculty, from basic research to full translational clinical trials. Our focus, our College of Pharmacy, focuses on several buckets. One, as you mentioned, being cancer research. And there's over 10 faculty that focus on cancer research in our college, from, like you say, breast cancer to colon cancer to pancreatic cancer to other cancers that have similar mechanisms that they happen to be looking at. For example, Dr. Ronenson has a cyclin-dependent kinase molecule that he looks at, and him and Dr. Brody have been a very successful team in studying a specific pathway and have developed a molecule against that cyclin-dependent kinase pathway that seems to work in all kinds of cancers. So cancers are different, but they're the same. They can have similar mechanisms. We have affinity group of neuroscientists now that are hugely successful. Doctors Francis and Porcu specifically we've recruited and are hitting the ground running. Of course, Doctors Zhu and Ronenson and that group also looks at neuroscience, Alzheimer's, and other neurodegenerative diseases. But importantly, our school also looks at addiction and behavior. There's multiple faculty looking at that. Big data and health outcomes. Our clinical pharmacy and outcome science faculty are, and some of our basic science faculty work with big data and big databases and look at outcomes of drugs, new outcomes of drugs. So we have to find that out. As we're working in the clinic, we have to find out the side effects. What if the side effects are cancer? Our faculty in the CPOS look at real-world data, real-world outcomes of drugs that are new. For example, we're looking at GLP-1 agonists. Dr. Joe Magagnoli is one that's looking at those, and Qingwing Teng, Eric, is also looking at GLP-1 agonists and the poor outcomes that might be associated with them. It's all happy, and people are taking these like candy right now, but we don't know the long-term impact of that. Our folks at CPOS are monitoring it, literally monitoring it, and they're collaborating with DDBS folks to ask the mechanistic questions. How does this work in animals? What are the mechanisms of this outcome that they might be seeing?
So I have to ask you, I understand that you're working on a book. Tell us a little bit more about that.
It's synthetic food dyes. There's this rise in early onset colorectal cancer since the 1990s, and this huge rise in synthetic food dyes since the 1970s and 80s, 10 to 20 years earlier. It takes 10 to 20 years for a cancer to develop, and it makes sense. So there's a temporal relationship. And all kinds of other things fell into this category as well. A general westernized diet, red and processed meats, obesity, antibiotic, the rise in antibiotics, MSG, titanium dioxide, high fructose corn syrup, all of those kind of fall into this temporal relationship. All of these also fall into, is the exposure global? Well, yes, it is. Synthetic food dyes are in most, if not all, ultra-processed foods. There has to be molecular evidence that these things, if we're talking about synthetic food dyes tickle the inflammatory machinery. So there's some data out there, independent data, that shows when they expose cells, for example, to synthetic food dyes, we see an increase in cyclooxygenase 2, which is a pro-inflammatory molecule. So we have a metric of temporal relationship, a metric of, is it global? Does it tickle the inflammatory machinery of the microbiome? The fourth is, are people generally exposed to these agents? And as I said, a bunch of them kind of fell into play, with the answer being yes to all four of those metrics, including antibiotics, by the way, but also synthetic food dyes. After being in this business for the last 5 years, I decided, well, I have the knowledge to write a book. And the book isn't out there. No real robust book that highlights in layman's terms the history of synthetic food dyes, the mechanisms of how synthetic food dyes cause cancer, the mechanisms of how it might affect the brain, and the mechanisms of how it might affect metabolism. So I'm addressing all of those in the book. I've invited Dr. Rebecca Bevins to co-author in a 50-50 co-authorship. She's a professor at Western Nevada College in psychology, and she has a very vested interest in synthetic food dyes. Her story is her son, who reacted to synthetic food dyes when he was an infant. And she has tracked, this is over 15 or maybe up to, I think he's 19 now. They've been tracking his synthetic food dye consumption and what happens and the outcomes of that. And she was very engaging to me. I thought she could add a lot.
Dr. Hofseth, it has been a pleasure having you here. Thank you for sharing such insightful information with us today. And thank you for tuning in. Remember to stay up to date with the latest in pharmacy education and innovation by following us on iHeartMedia, Spotify, and YouTube, where you can explore our full library of episodes. Until next time, I'm your host, Margaret Gregory, for the USC College of Pharmacy Podcast.